Hello and welcome to this lesson on standard form. First of all, we're going to talk about powers of 10. Now 10 times 10 times 10 times 10 is 10,000. And that can also be written as 10 to the power of 4 because it consists of 10 times 10 times 10 times 10. Similarly, 1,000 is 10 to the power of 3. 100 is 10 to the power of 2. 10 is 10 to the power of 1. And for this pattern to continue, 1 is 10 to the power of 0. 0.1 is 10 to the power of minus 1. And 0.01 is 10 to the power of minus 2. And finally, 0.001 is 10 to the power of minus 3. Now you see a pattern emerging here. When you have 10 to the power of 4, the number that it's equal to has 4 zeros in it. So it's an easy way to remember how many zeros correspond to which power of 10. Similarly, at the other end, 10 to the power of minus 3 is a number with 3 zeros in it if you include the one before the decimal point. Now think about this number, 2, 3 and lots of zeros. That's the same as 2.3 times another number that starts with 1 and has a lot of zeros. And writing them in line like that, the 2, 3 with all the zeros together with the 1 and all the zeros, you can see that the first number is 2.3 times the number that starts with 1. And if we count up the zeros, there's 11 of them, so that number is the same as 2.3 times 10 to the power of 11. And that's a much easier way of writing that number than having to write all of the zeros. And that's what standard form is all about. It's a way to write very big numbers, or indeed very small numbers, without having to write lots of zeros. And it's used for scientific quantities, very large things like distances between planets, or very small things like sizes of particles. And standard form is something between 1 and 10 multiplied by a power of 10. So for example, write 342 million in standard form. So starting with 342 million, we can see that it's 3.42 times 100 million. And it's easy to get the right number of zeros as long as you can remember to write numbers in line, like I've done there. And that's equal to 3.42 times 10 to the power of 8, because there are 8 zeros in 100 million. So that's in standard form. Example 2. Write 0.0000071 in standard form. So we start off with the number, and we need to think of a number between 1 and 10 that we get from that. So that number is 7.1. So 0.0000071 is equal to 7.1, a number between 1 and 10, multiplied by 0.000001. And again, writing your numbers in line makes it much easier to get the right number of zeros in that number. So 0.000001 is a small number with 6 zeros in it, including the one before the decimal. So what we've got is in fact equal to 7.1 times 10 to the minus 6. And that's in standard form because it's a number between 1 and 10 multiplied by a power of 10. So here's a question. 2.5 times 10 to the power of 4 times 3.2 times 10 to the power of 7. Write that in standard form. Well, we could rewrite that with all of the numbers first and all of the powers last. So I've rewritten that as 2.5 times 3.2 times 10 to the power of 4 times 10 to the power of 7. I've done that so that I can consider the regular numbers as one thing and the powers of 10 as another thing. So 2.5 times 3.2 is simply 8, and 10 to the power of 4 times 10 to the power of 7 we get by adding the powers to get 10 to the power of 11. So that number is equal to 8 times 10 to the power of 11, and that's in standard form because it's a number between 1 and 10 times a power of 10. Well, here's another question. 4.8 times 10 to the power of 9 times 7.5 times 10 to the power of 6. Write that in standard form. Well, again, I'm going to rewrite it with all of the regular numbers first and then the powers of 10 afterwards. So 4.8 times 7.5 times 10 to the power of 9 times 10 to the power of 6. So 4.8 times 7.5 is 32, and 10 to the power of 9 times 10 to the power of 6 is 10 to the power of 15, because you just add the powers. So we've got 32 times 10 to the power of 15, but that's not in standard form because 32 isn't a number between 1 and 10. So I'm going to rewrite that as 3.2 times 10 to the power of 16. So I've made the first number 10 times smaller from 32 to 3.2. And to balance that, I've made the second number 10 times bigger. So instead of 10 to the power of 15, 10 to the power of 16. So our final answer is 3.2 times 10 to the power of 16, and that's in standard form because it's a number between 1 and 10 multiplied by a power of 10. Well, there should be some questions for you to try on this, so go ahead, have a go at them.